Welcome to another GibbsCAM MTM video. This time we're going to give you a quick little review on how to do a complex MTM part using GibbsCAM. You can see I have my model already brought in. Has some ID work, end work, tapped holes, OD holes, some threading. I already brought my model in and oriented it correctly. Usually after you orient your part and get your origin where you'd like it, normally you go to view and do shrink wrap visible. This will wrap material around your outer boundaries. Now here you can open up your document page and you can change these values as you need to. This did a shrink wrap, did a 3-inch on the Z. I'm going to add 1/8 of an inch, so there's some material coming out. I'm going to have it sticking out of the jaws 3 3/8, so my jaws are going to be over here, and my material is 3.5 inches long. It's actually going to be 3.625 because I'm going to add 1/8 of an inch on the back end as well. Over here, my clearance values. Now remember, on MTM, the MTM product is for your specific machine. So when you get a MTM post processor from Gibbs, it'll have your specific machine here. Same with some of these others here, and all the details about your machine. It knows how many turret stations there are, clearances between spindles, etc. So on here, my material is 3-inch. I'm going to wrap it to 3.1 and 1/4 inch away when my tools come back and forth from the machine. Now I'm not going to play with the SubSpindle yet. We'll wait till we transfer that over. So I'm just going to concentrate on the main spindle here. And I'm going to say it has initial stock, so that means your stock is in the spindle already, preloaded. And this graphic part face distance, I'm going to put 12 inches there. Now that's just the distance between the parts on Gibbs on your screen. Your machine is probably 24 to 40 inches, but that does not matter. This is just graphic part face distance, because you don't want to keep panning your GibbsCAM screen to look at the main and sub spindle. So if I bring up my viewer and unzoom, you can see it shows main and sub spindle. I don't want to have to keep panning and zoom this up to work on it. So for right now, I'm going to click on this button and turn off the sub spindle. So now when I click on no zoom, all it does is zoom up the main spindle. And you can do the same thing when you get to the sub spindle. So the next thing I want to do is I want to extract some geometry and create my tools. Now extract geometry on MTM or any turning, it's really easy. Click on your model. You can go up this button here and click on Slice Spun Body. What that's going to do is Gibbs is going to give you the geometry of the part as if it was spinning in a lathe. So I'm just going to extract the profile there and turn off the profile, and you can see I have all my geometry to do all the turning. Now I have created 2 work groups. One I just called it turning, one I called milling. Okay, you can make as many as you like to separate them in different layers, but I just have turning right here. Okay, next I want to create my tools. I've already created my tools here for this, and we'll just kind of go through this a little bit here. Tool number 1 is going to be in station number 1. Okay, with MTM it does not matter where you put them in this list, because the turret location and offset are designated here in this page here. So it's going to be in position number 1. Now Gibbs knows, since it's MTM and it's a NL or NLX, it has 12 positions on here. I'm going to use offset number 1. Okay, and I'm going to have it to be a tool holder. You give it your tip radius, your inscribed diameter, thickness, so on and so forth. So this is like a CNMG 8-degree diamond here. And I want the insert face down, so I'm going to uncheck this. You can see if I check this, it puts the insert face up, so that's going to be an M4 versus unchecking an M3 in most cases on most MTM machines. Okay, next tool is going to be 1/8 inch, or sorry, 1 1/8 drill sitting in this direction. It's just going to be a static tool. Position 2, offset 2. Next tool, boring bar in station 3. 55-degree station 4, grooving tool station 5, a facing mill in position 6, and 7 will be a OD radial live tool, drill 5/8. Actually that's going to be a spot drill, and a 1/2 inch drill OD as well, radial live, and that's position number 7, tool length 7. Now I usually put spaces between tools that are in the main spindle, tools that are in the sub-spindle. You can put these anywhere you want. I just put a few blocks between so I know the difference between the tools. So this tool, in my first tool in spindle number 2 for my sub-spindle, is also going to be position number 1, just like this one up here was, but we give it a different offset, okay, because there's going to be 2 tools in that station, one facing the main, one facing the sub. Now on the NLs, the standard offset is any time you add a tool to the sub-spindle, it adds 16 to the offset, so that's why that's 17. You can see 3 will be 19. You can see the rest of these will be the same. Okay. So since the OD is a turning tool, position number 1, that's in turret position number 1. And your offsets, you can see so on and so forth. The last one is going to be in position number 8. And this is the live tool holder that has milling on the front and back. It's a actual holder. So this is going to be also in position number 8, just like this one is. But you add 16 to it, that equals tool length offset of 24. So we have all our tools ready to go now. Okay. Now I'm going to have, I already have some processes done, so you're not watching this video for an hour. So I'm going to go through these on how I created them. First thing I want to do is face this off. Remember, I have an 1/8 of an inch material to face off. So on here, I'm just going to open up this process, and we're going to do front face with tool number 1. I'm going to wrap it a 1/4 inch away because I have an 1/8 of an inch material, and there's where the 1/8 of an inch comes in. 50 thou depth of cut, and I'm going to leave 3 thou for finish, and put in my constant surface feed, etc. on here. I'm going to click on that face, drag it to the OD there. I want to cut to the bottom there, and I'm going to face it all the way down to X0. Okay, that is done. The next operation I want to do, same tool, I'm going to rough out the OD here. So here it brings up this process, OD, tool number 1, 3.1, 3.1 to wrap it to and wrap it out. My material is 3 inches. Depth of cut 1/8 inch, constant surface feed, my feed rates. It'll leave a little bit of stock on the OD, a little bit on the Z. And this time I'm just going to click on this, start off my part. If I want to start a certain distance, I can say start 1/4 inch away, and it'll put it 1/4 inch away. That's up to you. I'm going to hold the control shift down. It'll snap to this line. I want to go just a little bit past there, and I'll just click on redo it in this case. Okay, so we have the face, OD done. Next thing I want to do is drill. So that's going to be with tool number 2. And I'm going to just feed in, wrap it out, wrap it a 1/4 inch away, and when I'm done 1/4 inch before it goes home, does a tool change. And this here, this button, let me just 0 that out. I'll highlight it again to show you. Just need to hold down the Alt key in Gibbs, and you click on the end of your part, and you can see that puts in 3.5. Well, my material is actually 3 5/8 down to here, so I'm gonna I want to make sure the full diameter is through there a little bit. So I'm going to go -3.7. That should get plenty past that. Okay, put in your RPM and feed rate, or you can just click on those buttons and it'll fill in the suggested feeds and speeds for you. Okay, next thing I want to do, rough the ID. This time I'm going to choose front ID, 1/8 of an inch. Remember the hole I drilled in there was 1 1/8, so that's where I'm starting, 1 1/8, 1 1/8, and 1 1/8 when I wrap it and I'm done boring that hole. 1/8 inch depth of cut, a little bit of stock here for finish. Now this I have multiple processes going, so I'm going to use the same tool to rough and finish. So the second process is the same thing, front ID, and actually on here I could probably start pretty close to this point. I'll click that, so 2 1/4. And I probably want to do a little 90-degree line there. So it'll come in, do a 90-degree line, then take a finish pass on there. And we have everything in there. So I'm just going to click on that there. I want to cut down. Again, hold Control Shift, click on that line, a little bit past there. And I'm going to click on redo in this case because I already have processes done. And there we have that. Next thing is tool number 4, which is our finish tool. Going to bring that up. This is going to be an OD, and I want to bring it, since all my material is pretty much gone there, might as well have the tool start pretty close to here. So I'm just going to highlight this button here and hold the Alt key down, click that button. That tells me that's 1 3/4, which is great. When it gets done turning this, I want it to go off 3.1. And I'm going to go to 50 thou line there. Now make sure you uncheck that, because if that is checked, I will show you here. Start about this point here. Cut that direction. Finish past here just a little bit, and I'll click on redo. Now notice the tool comes in, and plunges here, which we haven't taken material out yet. So I don't want it to do that. I'm just going to click on uncheck the X minus, click redo, and you'll see it'll be nice and straight across there. So next I want to cut the groove now. That's tool number 5, our grooving tool. So I'm going to wrap it to 3.1 and 3.1 when I'm done. And instead of choosing turning, I'm going to choose plunge, and I'm going to go 90 degree, minus 90 degree actually. And calculate means it's going to 100 thou max is the maximum step over I'm going to allow it to do, or I could go exact, but I want to go calculate. And I want to start in the center. Okay. And over here you have full or material only. Full means it's going to cut where you designate with your geometry here. Material only, it's only going to look at where material is left over from the previous tools and only cut that. So I'm going to use that, stay 20 thou away from anything else I've cut. Finish stock, I'm going to leave 5 thou, so that means it's going to leave 5 thou here, here, and here, and here, which is great. Put in your RPM and feed rate, and you want to make sure this is checked on, so it will go down in there. Now I have multiple process on here, so the same tool is going to finish. Again, 3.1, 3.1 is fine. Material only, make sure that's checked on. Nothing here, so it's going to come back and take a finish pass. Now I don't want the tool to come down here and then drag up here. So if you uncheck this, or I mean check this, that means it'll push the tool down to here, push the tool down to there. So I'm going to highlight this, start off my part a little bit, and here a little bit off my part. We'll click on redo, and there I have my tool path there. Now anytime in Gibbs you can render what you've done so far and see how it's done. You don't have to wait till you're all done to see how you're coming along. So let's do that. Okay, click on my cut part render. We'll slow it down just a little bit. We'll do a quarter cutaway here. That's half, there's full, there's quarter cutaway. And we can see the first thing we're doing is going to face it off. Take that tool, rough the OD, drill, rough the ID, speed it up a little bit, and finish pass with that same tool. Finish pass with the OD, and groove, and finish. So far, this is where we've gotten. Okay, let's go back to our programming now. So operation number 6 is going to be our operation number 9. Tool number 6 is going to be facing these flats off here. And I'll show you a cool way to do that. I'm going to turn off my cam palette, and I'm going to choose the YZ plane because that's the plane we'll be on. Click the home view, and you can see your part there. I'm going to bring up geometry because I'm going to actually draw some geometry to cut this. So I'm going to click on, first make sure you select the tool that you want to use, in this case the 2-inch face mill. I'm going to click on line and mouse line, and you can see as I move my mouse off, there is my cutter. So it's really handy. So I'm going to get my cutter close to there, and I'm going to be looking at these numbers here, and I want to start out at Y0, no need to have it offset there. So when that's Y0, I'm going to click my mouse once, and I'm going to drag it just like it's cutting. And I just want to barely go past this radius here so I get the nice flat. So when I pass there just a little bit, I'm going to click again. You see my tool path, press escape to get out of there. Now you see how you have the line to do the milling. Now if you want to move that up to that surface, that's fine. You really don't have to. But if I wanted to move it up to that surface, I could, and you can see now it's there. Okay, so now I want to program the facing. So that's tool number 6. So make sure before you add any values or do the toolpath, you click the rotate tab, make sure you're on the correct plane, which is the YZ plane on the main spindle. I'm going to do position milling, which means it's going to rotate every 60 degrees to do the 6 sides on there. And I'm going to duplicate it 5 times every 60 degrees. So here we know our material is 3 inches because that's what we start out with stock. Let me just zero this out here. And I'm going to have the Alt key pressed when I click on this flat, and you can see it puts 1.38909 in there just fine. Choose your RPM and feed rates, whether you want to leave any stock or not, and where you want to wrap it away from. And so everything looks pretty good there. Now this time you want to choose, you don't want to choose the outsides, you want to choose right in the center because that's where you drew the geometry. And I'm just going to click on redo, and you can see there's our toolpath so far. And if we want to render, we can do that. Let's just turn on our simulation, and we'll speed it up a little bit just to get to where we left off. So we did the groove. So the next thing now, operation number 9, is facing the part off. Okay, so we face it off. The next operation is going to be drilling. Okay, we need to pull geometry off the part for drilling. I'm just going to delete these 2 just to show you how I pulled them off. So bring our part up, make sure you're in the YZ plane, which we are because the tool is going to come from the outside to drill and chamfer this hole. And I'm going to turn on edge selection. I'm just going to select this edge, hold control this edge, right click, extract the geometry, which is just great. And there we have our geometry there. Okay, so I'm going to bring up my tool number 7 and tool number 8, multiple process here. Okay, I'm going to make sure I'm on the YZ plane first, and again this needs to be 6 times around, so I'm already doing the 1 hole, so 5 more times every 60 degrees will work just fine. Okay, now I want to know, I'm just going to zero that out, I want to know where this flat plane is, so I'm just going to hold down the Alt key, click on that, and you can see it's 1.38909 is where that is. And to get the depth of the hole, if you like, you can click on this here, because this will be the point of the drill. You can click right down the bottom of that point, and it's going to put 0.6887. That is from X0 there, and that should get you your, let's just make sure I'm right there on the point. Okay, should be good. And everything's good there. And my second process is going to be with the tool number 8, which is actually our drill. Actually, I want the drill to be down there. Sorry, and not my chamfer. My chamfer is tool number 7. So I want to make sure I get that diameter right. So actually, instead of going with the depth, I'm going to say cut this diameter. So I'm just going to click on Alt-click this on the diameter. It'll fill in the blank and fill in the depth for me automatically. Okay. Select my hole, click on do it or redo, depending on what you're doing. And then we're up to the next step here. We're all done with the main spindle now, so let's go ahead and render that. So turn on our rendering. Let's unzoom it a little bit and rewind. Okay, let's click play. Drill, rough. Speed it up just a little bit. Spot drill, drill. And we're where we need to be to transfer to the SubSpindle now. Okay, transferring to the SubSpindle, in every MTM product, you'll have this utility tile here. So I'm going to bring up the utility. So what I want to do first is I want to get the turret out of the way of the part before the SubSpindle comes up and grabs it. So I'm going to bring up a utility tile with the tool I want to use in that position before it moves, in this case station number 1. So you bring up a utility tile with station number 1. I'm going to do what they call a move tool group. You can see there's a lot of choices there. I just want to move the tool. So move the tool out of the way from the main spindle. I want a new location. So the X, I want it to go home, so it's going to be way up in the machine home there. And the Z, I want to bring it to right to Z0. And I want to do it with the part, ZX, not the spindle, but the part, and actually the tooltip there. So I'm going to bring the turret right over to Z0, so that's good clearance for the SubSpindle to come up and grab it. So the next utility I'm going to bring up now is going to bring SubSpindle in. Okay, that's in this list here, SubSpindle in. The part is in the main spindle. There's no part in the sub. I'm going to do it with the spindle on, so the air blow will come on and blow my jaws off to get all the chips off. Forward, you put in any RPM you'd like, and I'm going to sync the C spindle so that all the holes and all the milling I do from the end and here, everything's timed together when it goes to the SubSpindle. Now the Z clearance, I have 150 in there. Usually I start out with 1/2 inch or 1 inch in there when I'm proving out a program, and then I'll move it closer when I'm actually doing production. Feed rate onto the part, usually I start out 20 inches a minute, and I bump that up as the everything looks good. So 20 inches a minute, and then how far do I want to grip? So I'm going to zero that out for right now. I'm going to make sure I'm back on the XZ plane. I'm going to highlight this button, hold the Alt key down, click here, and I want to grab it on minus an inch there. So between here and here is an inch, so I want to grab it onto an inch. I'm not doing any shift angle there or anything like that, so I'm going to click on redo. So now my turret has gone over, the SubSpindle has now come up and grabbed this. Now the next thing I want to do is I want the SubSpindle to return. Again, feed rate 200 is just fine, spindle on, same thing, 500 RPM with the part, and I want to open the main collet. If you don't click on the main collet, the SubSpindle will try and grab the part and pull it out of the main spindle and not be successful, because usually the main spindle is larger. So make sure you have this on, and you'd probably check on, actually we'll just leave that main loaded there. So we'll redo that. Okay, now on my operation list, I'm working on the SubSpindle now. Okay, that says T12 down here, T12, but it's actually station number 1. Okay, but before we do that, we need to turn on our SubSpindle. We'll unzoom it, and I want to move the geometry for the turning as well as my solid model over to here. Okay, so I'm going to turn off my cam for just a moment. I'm going to stay in the ZX plane here. I'm going to highlight the geometry, hold the control key down, and highlight my solid model. I'm going to go to modify, duplicate, and translate. Now remember, our part is 12 inches between here and here on the graphics, and our part's about 3.5 inches. So I'm going to put 12 plus 3.5. Now you can get it exact if you want to add the 1/8 of an inch here and here, but I'll just show you how to adjust it after just by doing that amount there. So you just want to do it one time in the Z, so click on do it, and you can see we're pretty close there. We're not quite on the money. Okay, like I say, you can calculate exactly if you want, but I'm going to show you how to move that to where you need it to be. Now one thing you got to remember with solids, when you duplicate and translate a solid or move it or rotate it, they still are one, so you need to separate them. So you open up your 3D palette and you click on the scissors, which will make them 2 individual pieces. So now as I move this one, it's not going to move this one. Okay, so for right now, I'm done with the main spindle, so I'm just going to turn off. I just go to SubSpindle, turn off the eye on the main spindle. Now when I click on no zoom, it's just going to zoom up the SubSpindle now. I'm going to go to the coordinate system that says ZX plane SubSpindle. And I'm actually going to tell it that this geometry and the solid is in the SubSpindle. it's related to the SubSpindle. Remember, we just duplicated and translated it from the main, so that's why everything thinks it's everything was drawn in the main spindle. So that's just easy to do. Just highlight the solid, your geometry, and just right click and click change that coordinate system to the SubSpindle. Now you can differentiate between the main and the sub. Let me just turn on the sub momentarily. You can see the purple geometry. That means it's in a different coordinate system. If I right click and say move to that coordinate system, you can see that's the ZX plane main spindle. If I right click on here, that's the ZX plane SubSpindle. Okay, so we'll turn off main, unzoom. Okay, now we have everything in our SubSpindle. We just need to adjust the where the Z is, the Z0 on the front of our part. So I'm just going to bring up our mouse position here, and I'm going to click on it there, and you can see. Bring my mouse over here; it'll be a little easier to see. See if I click on here, you can see that's 0.05613 from Z0. Okay, so we need to actually move it back that same amount. Okay, so let me just click on that again. Let's just actually dimension that. That'll make it a little bit easier. Okay, we're 0.0561 away. I'm going to highlight the solid, highlight the geometry. I'm just going to translate it in Z. I'm going to go negative 0.0561 in Z. And now you can see we're right at Z0 there. Okay, let's turn this off here. We'll turn off the dimensions and we'll unzoom. So we have the SubSpindle now correct as far as the Z0 goes. Now we have to add a little bit of stock to the SubSpindle. So let's turn on our document page again. This time instead of the main spindle, we're going to go to SubSpindle. Okay, so these change a little bit now. Our clearance plane is going to be 3.1, and remember we have going to have an 1/8 of an inch material from the transfer, so I'm going to again say that's 250,000 stock. It's not initial stock, we're grabbing it from the sub, so you don't check this graphic part. Face distance still 12. Remember we have an 1/8 of an inch in front of there. And if we do a little math here, when we do the graphics, this will help. So our overall part length is 3.5 inches. Remember we left an 1/8 of an inch on the front and back, so that's 1/4 inch. So actually we have 3 1/4 overall length of material. Remember when we did the SubSpindle coming forward, we grabbed it on an inch. So if I subtract an inch, that makes it 2 3/4 out there. And we have the 1/8 of an inch sticking out, of course, on there. We're going to leave this right here for now, and we'll show you how we can adjust that later down the road. Okay, so operation number 12 is going to be facing off. This time make sure you select SubSpindle, not main, but we're on the SubSpindle now. Front face, make sure you have the correct tool in there. Okay, pretty much the same thing as before, but now we're on the SubSpindle. I'm going to take a little bit less cuts there, depth of cuts, just because we're holding onto the sub. And again, I'm going to highlight that up to there. We're going to cut down, and since we have the hole drilled through, I'm just going to go a little bit below that. Okay, should be good, and we're going to just redo that. Okay, so now I have faced off. Next operation is going to be to rough all this material out with the same tool. Okay, again, OD, material's 3 inch, 1/8 of an inch cut, depth and everything almost like our main spindle there. I'm going to start out there, a little bit off our part, and I'm going to probably just end right about there. Okay, make sure you go in the right direction, and we'll just redo that. Okay, again, make sure you have that unchecked, otherwise the tool will dive in there and you won't get a can cycle. Okay, next tool, 14, is going to be our finish tool. Again, OD there, 3.1, 50 thou on there. Start there and bring it down just about right there. We'll let it snap over to there in that direction. Again, on this edge, out, redo that. Now you can see our finish tool paths up and out. Okay, next thing I want to do, groove. Basically almost the same tool, but in the SubSpindle now. Again, 3.1, OD, -90 almost the exact same thing we have on the main spindle there. Okay, I'm going to highlight that and up to there. There, make sure you choose the right direction and redo, and now we have our groove finished. Okay, next operation, rough out the ID. Okay, and actually we're going to start on this little chamfer out here a little bit so we get the chamfer on the finish cut. I'm going to end right there, and we're going to rough and we're going to finish there. Okay, we'll do a little bit of a line there. Okay, we're going to redo that. So now we have our rough and finish there. And next we're going to actually, let me change this a little bit. We're not going to use material only. We're actually going to do full. And we have 1/8 of an inch there, so everything is pretty good there. So we were good in the first place. Okay, next I want to drill the holes in the end, but before we do, I need to pull off some geometry on there. So I'm going to rotate this around. I'm going to turn off our cam palette for a moment so I can pull the geometry off there. Just click on this, turn on face selection, click on this face, and right click, and go down to extract edges. And there's all my geometry I need for that hole. You should be on the XY plane though in the SubSpindle. Okay, now I have all the geometry I need to cut those. Okay, so my next operations, I'm going to do 3 processes here. Tool number 17 is going to be the spot drill, drill, and then tap. So make sure when you're setting up these processes, the first thing you always do is make sure you're on the correct plane. Otherwise, these numbers will not be correct here. So I'm going to do a 1/4 inch chamfer on here. That'll get this little chamfer on the end there. Fill out your RPM feed rate. The next process is going to be tool number 18, which is your 177 drill, and then your tap. So in this case here, I'm going to do position milling. So this is small enough to where I can hold the part with the brake and go around to each hole using XY coordinates. If I did polar and cylindrical, it would do the one hole, then rotate C, next hole, but I have enough room here to do that, and it's usually a little bit faster sometimes. So I'll click on the hole. I just need to click on each of the holes there. Since I'm doing XY location, and we'll just redo that. Okay, now we have just about everything done. I'm going to show you well, one last thing, threading, sorry. Again, make sure you're on SubSpindle, and I'm doing 2 1/4 by 8 threads per inch with my tool, and we'll just redo that. Okay, now we're done except for the part unloading, and we'll show you that last of all. So I'm going to save it. We're going to bring back the main spindle so we can see both the main spindle and the SubSpindle cutting. Okay, let's bring back our rendering. Okay, we'll rewind it. We're going to show both the main and the sub. So let's turn on the main and the sub, unzoom it. Okay, we'll slow this down a bit so you can see everything here. Okay. And right now I show material in the SubSpindle, which is okay for now. We'll show you how to fix that. Okay, so I'm roughing the OD. Before we get too far, I'm going to click on this button that says stop before the unload. Okay, that way you can see it transfer a little bit better. Okay, so now everything is ready for the SubSpindle to come forward. I'm just going to single step through this. So the SubSpindle comes forward, grabs it, brings it back to the back spindle, and you can see everything back here is what we did on the main spindle. So you can see Gibbs remembers what was cut on the front side and transfers it to the back side. So you can see that right there. Okay, let's continue with the rendering. Okay, facing that off, OD cutting. Finish. Now you're going to see it a little bit off here. Remember we talked about moving the geometry to make the rendering look better. We'll turn on the quarter cutaway there. Half cutaway would be a little better. Okay, then we're doing the grooving there and the drilling. So spot drill, drill, tap. There's our tap. And then threading at the end. Now, of course, threading, you want to make sure if you're on the SubSpindle, you have the insert facing up. Otherwise, you'll have left-hand threads and not right-hand threads. So now our part is finished. Okay, looks pretty good there. Let's unzoom that a little bit. Now, one thing that's nice when you're using MTM or anything is to turn on the geometry. So let's go ahead and do that now. So by clicking this button down here, it turns on the geometry. So that way you can check your rendering along with your part. And everything looks pretty good there. So we'll render it again. Transfer to the sub. And everything looks good there. Okay, we'll turn off the geometry there. So the last thing we need to do is unload the spindle, because if you don't unload the spindle, it's going to leave the part in the SubSpindle, and then when it transfers and goes to the main spindle, it's going to push this part into your main spindle. So the last utility we need to do, I'm going to bring one last utility up, just drag a utility down there, and this time we're going to do unload spindle. And you can either do it by manual chuck or parts catcher. This will just use the parts catcher. And it's going to be a SubSpindle. And the Z position, I want to bring the Z a little bit closer to the parts catcher before it dumps it into there. So I'm going to say minus 10 inches is usually pretty good. Feed rate, we're going to start out with 20 and approximately 10 seconds it takes to unload that. And we just click on do it. So now, if I unzoom everything, and we turn on our cut part render and rewind, you're going to see there's nothing in the SubSpindle now. So when we render, we transfer over main to SubSpindle. And that's a quick little demonstration, not very quick, but demonstration on MTM, how quick and easy and fast it is to do in GibbsCAM. Thanks for watching.